Hi, Assalamualaikum warahmatullahi wabarakatuh. Welcome to chapter 6. So, in this chapter, basically, we'll be looking at the idea of functions and how you can have operations on functions, and then we'll move on to look at linear function and some ideas on how functions can be sketched via transformation of functions. So, here, in this section 6.1, you will see that the idea of functions come from a very simple word called relation. Relation means two or more things that have something in common. So in the simple words, in the simple scenario, we can say a brother and sister are related because they have the same parents. In mathematical notation, when you talk about relation, you talk about having ordered pairs in the form of x and y. So x is independent variable and y is dependent variable. Okay, the types of relation are one-to-one relation. Okay, there are four types of relation: one-to-one, many-to-one, one-to-many, and many-to-many. And this relation between two sets here can be easily represented using a simple technique called mapping. So this is what we call mapping, and based on the first figure, you can see that this is a relationship of many to one. You can see two different people here being assigned to one output. For example, Stephen has shoe size 5 and Bruce also has the same shoe size, so many to one. Over here we have a one-to-one relation. Each person is assigned to one specific seat. Okay, this is many, this is many to many, where you can see that this book can be borrowed by two students, and for example this particular student can also borrow two different books, so the relation is many to many. And finally, this is an example of one to many. So one particular flight can have many attendants, flight attendants. So in this case, this flight have two flight attendants, Ramki and Sheila. Okay, next. So therefore, a function is a special type of relation where the situation is that in order for it to be a function, in order for relation to be called a function, it has to satisfy this statement where each input has exactly one output. So f here is the function, x is the input, and y is the output. Sometimes you will see that the notation used to represent a function is in this manner, but throughout the course you will see that I mostly use this notation to represent a function. Nevertheless, this is something that you should also be familiar with, so I introduce it here to you guys. So this is another notation for function. Now, based on the definition above, can you determine which one of these figures defines a function? So for the first figure here, clearly this is a function. This is a function because you can see that P here, the input P is given to output D, Q is given to B, R is given to C, and S is given to A. Each of them has one single output. Whereas for this one, this is not a function because you can see that Y here, Y is the input. However, even though Y is, Y is the input, but there are two outputs being assigned to 1, so y can be the output of y can be C or D, so it violates this statement where we only want to have one single output. The same thing for this one. This is not a function because, like, as you can see here, this is your input 0 and the output given here is either -2 or 1. Okay, for this one you can see that this is input. The first input is given to 4, the output is 4. -2, the output is also 4. 3, the output is 9. -3 is 9. So you can see that each input has one output, exactly a single output, so this is a function. So based on this, you can see that the relation, which is 1 to 1, is a function, and the relation which is many to 1 is also a function. All right, next. So other terms that you should know are what we call domain, codomain, image, and range. And these are given, explained as follows. So the first one is input. What is input? Input, when you talk about a particular input, it is usually denoted by X. Okay. But when you have a collection of all possible input, it will be represented by a set. So we have a set of X and it is called domain of a function. Now, when you talk about a particular output, which is value of a function at X, okay, it is denoted by Y or Fx. So this is the notation used for a particular output, and other name for that is image of X. When you talk about the set of all possible output, okay, if you talk about the set of all possible output, these are two slightly different definition for that. Okay, so the first one is codomain of a function. Codomain of a function means you have the set of all possible output that could possibly come out of a function, which is represented by set Y. But another definition is for range or image. Range or image refers to the set of all actual values produced by the function. Now this might seem a little bit confusing, but I think in the next slide you will see where the difference is between codomain and range or image. Now this graph here represents a simple idea that links domain, codomain, image, and range. So this is the domain. So a particular input is X. Of course, there could be a lot of other inputs. So this could be X1, X2, and Xn. The same thing, this could be Fx1, Fx2, Fx3, and so on. So the link between x1 and fx1 is given by a function f, and if you have a set of all possible outputs, so these are given in this area, which is codomain, and I hope you can see that the range is just a subset of a codomain. So this brings us to the next question, whether there is any difference between codomain and range. So in some of the questions given, for example, codomain is made to be part of the definition of the function, whereas the range is the set of actual values that are obtained. So as an example, consider this function. This is function fx is equal to 2x, and suppose that it is stated explicitly that the domain and codomain considered here are all possible integers. So what are integers? Integers can be positive and negative, and it takes like one whole number. For example, it can be, I don't know, -10, -3, or I don't know, 2, 25, whatever, as long as it is integer. So you can see that even though codomain is defined as possible integers, but if you substitute these integers into the function, the final results that you will get are all even integers. So the result is narrow down a bit more. So you can see that the codomain contains, so this is codomain. So codomain contains all possible integers. It could be um, possible in sorry I'm sorry it could consist of whatever integers, but the range here, which is the final results that you got, so this is the range or image, it will always be even integers. You multiply with 2 and you will get even integers, so those are the range. Okay. Now, based on the diagram below, determine the domain, codomain, and range. So clearly for this one, domain is A, B, and C. Codomain, clearly you can see that it could be E, F, G, H, I. And the range or image is what actual values obtained when applying the function. Is just F, G, and H. Okay. Now let's look at the next example. Okay, given fx is equal to 4x minus 8, x is a real number. So this is actually the definition of domain. So the domain, like I said, is the set of all possible values of x that can be plugged into this function. So when it is real number, that means it can goes from -infinity to infinity. Okay, it can be integer, it can be in decimal point, it can be whatever that you fancy. So now the question is asking you to find f3. Okay, so f3, so for question A, I'm going to change this notation to what I am familiar with. So this is actually fx is equal to 4x minus 8. Therefore, f3 is equal to 4 times, we're going to substitute 3 into x minus 8. So 12 minus 8, and the answer is 4. So this is a simple example just to illustrate how you substitute the value of x into a function. So next, the value of x if its image is equal to 32. So image is y is equal to 32, and y is actually fx. So fx is 4x minus 8. So we're going to substitute 32 because 32 is the image, is equal to 4x minus 8. So you want to know what is the value of x. 4x is equal to 40. X must be equal to 10. Now for question C, the value of x until fx is equal to x. So here I will have this equation, fx is equal to x. What is fx? You can substitute 4x minus 8 is equal to x. Okay, so fx is equal to 4x minus 8. Now 4x minus x is equal to 8. 3x is equal to 8. X must be equal to 8 over 3. So when x is 8 over 3, fx will also be 8 over 3. Okay, finally in this section 6.2, you will see that there are 5 ways to represent any given function. The first one is mapping. You have seen that in the previous example. The second one is ordered pairs. Ordered pairs, so this is an example of ordered pairs. So this is x this is y, and x is usually the independent one and y is the dependent variable. Okay. Table, this is also normal. You will list down the value of x, and then y is a specific function, and so you substitute x into that function and you will get the result. So you present it in using a table. Using an equation, this is also something that I believe you have seen before. So this is a function represented as an equation. And finally, you can represent a function using graph. For example, this is a linear function. So this graph is a linear function and it is represented using a graph. Okay, that's all for today. Thank you very much.